Okay, good morning, ladies and gentlemen. Please allow me to extend my sincere greetings again to thank you for taking the time to join us here this morning to witness the FY17 Autodesk new product launch and also experience those new features coming along with the new release. I'm Richard Lee, Greater China Regional Director of Autodesk. So I would like to share with you all of our faith in design today and tell you how Autodesk is ready for leading the future of making things. Well, we all know that Autodesk's vision is to help people imagine, design, and create a better world. But what does all that mean to you and also for us? If you've ever driven a high-performance car, admire a towering skyscraper, use a smartphone, or watch a great film or movie, chances are you have experienced what Autodesk customers are doing with our technologies and softwares. Over 200 million people, customers, including design professionals, engineers, and architects, digital artists, students, and hobbyists, software to unlock their creativity and solve important design, business, and environmental challenges every day using our software. But now we are entering a new era. The way things are being designed and made is radically transforming, and Autodesk is transforming along with it. By 2020, it's predicted there will be 50 billion web-connected devices. Agility, mobility, and connection. That's what today's technology is all about. Cloud computing, mobile technology, social connection, and collaboration. These are the technology trends that will dominate the years to come, and Autodesk will be right there to offer its customers every opportunity to leverage the power of these technologies. No other company can provide a critical insight across industry the Autodesk can. The future of making things is already here and now. And what we are seeing is a convergence of how things are designed and made across all of Autodesk industries, including architecture, building and construction, infrastructure, media entertainment, natural resources, and manufacturing. Construction companies today are operating more like manufacturers by prefabricating and assembling things like apartment units, exterior walls, and ductwork. Media entertainment industries companies are behaving more like car brands by planning and pre-visualizing their entertainment properties like film and games long before production, just like an automotive manufacturer would plan and develop a concept car. So people from all industries will face similar challenges and need similar capabilities. And what's common to all of the industries we serve is the relationship between designing, making, and using. Those three elements are converging fastly. As sensors are embedded in places, things, and media, we have the opportunity to send real-time, comprehensive, and factual feedback to be incorporated in future designs. And as the link between designing and making gets closer and closer through advanced manufacturing and the development of more connected places and things, the feedback loop gets even tighter, and it becomes possible to respond to feedback even more quickly. And finally, as designing, making, and using converge, the boundaries between designing, making, and using disappear gradually, but very fast. Things will change and respond in real time to feedback from use and their environment surrounded. So let's talk about each of these in turn. The nature of design will be increasingly collaborative. As technology connects more and more people into more complex projects, we're going to see global virtual teams and collaboration on a scale unheard of previously. Our access to capital is changing. Crowdfunding lowers the barriers of entry and creates more opportunities for market research. With greater access to capital, it levels the playing field between small and large companies. Now ideas and products of the future can come from individuals, companies of any size, and from any part of the world. And our computing infrastructure is dramatically transforming. access to virtually infinite computing power, provides vast amounts of data anytime, anywhere, through cloud, social, and mobile technology. On the make side, methods of production are changing. We simply don't design, manufacture, or build things the same way as we did before. Access to complex production methods like prefabrication means you can bring products to market faster. It's also getting easier to access the supply chain, easier access to the infrastructure of manufacturing, like micro factories. Allow disruptors to participate in the capital-intensive world of making. With micro factories, you can retool quickly and produce materials for multiple businesses and consumer types. This means less reliance on cooperation in traditional factories. Now startups and entrepreneurs can compete with large corporations without investing tens of millions of US dollars. And finally, we have changing consumer demands. Off the shelf is no longer good enough. And with the rise in new making technology, we are seeing a corresponding demand of customization of products on massive scale. When it comes to the use side, we're seeing a greater integration of digital and physical. Digital systems are becoming deeply integrated in physical things and are creating complex interrelationship among physical objects. And this is becoming controlled through mobile and cloud technology. And we're now seeing how software can have the ability to actually change the nature of physical objects. And thanks to all of those changes, what we are seeing is a new generation of players who design, make, and use things in profoundly different ways. The competitive landscape is changing quickly and will soon be unrecognizable. Huge companies with access to nearly limitless resources no longer have some unique or huge advantage. The playing field is being leveled. It's all about who innovates first. And innovation no longer has to trickle down. Now it means in more cases, it becomes more trickling up. 3 examples I'd like to share here of how these technologies from design, make, use are being used in the real world, from the worlds of aerospace, consumer goods, and infrastructure. Here you see that it's the case Airbus and Autodesk collaborate to design and make the world's largest 3D printed airplane cabin component to date, AKA the bionic partition. This example touches on 2 major hallmarks of the new future of making things: using generative design, additive manufacturing, and new materials. Generative design capitalizes on the cloud to compute very large sets of design alternatives, hundreds to thousands, that meet specific goals and constraints because the designs created are nearly impossible to manufacture using traditional methods. Additive manufacturing techniques like 3D printing are critical to generative design success. In this case, the bionic partition was created with custom algorithms that generated a design that mimics cellular structure and bone growth, and then produced using additive manufacturing techniques. This pioneered design and manufacturing process renders the structure stronger and more lightweight than would be possible using traditional processes. In air travel, reducing weight means reducing fuel use. Designing in a structurally strong but lightweight micro-lattice shape, Airbus' new bionic partition is 45% lighter than current designs. When applied the entire cabin to the current backlog of A2020 airplane, this change of new design means it equals taking off 96,000 cars off the road every year. In a similar example from a totally different industry, athletic apparel, Under Armour collaborated with Autodesk to generatively design 3D print a new performance training shoe called the UA Architect. Autodesk software was critical to the team at Under Armour achieving some of the key goals for the shoes. Notably, Autodesk Within was used to generatively design the lattice midsole for a stable heel structure with the proper elements of cushioning for strength training. Again, generative design is a pioneer technology central to the future of making things, where a computer algorithm creates structure based on design criteria like durability, flexibility, and weight. It results in complex, high-performing structure that human designer would never conceive of otherwise. And as is the case with the UI architect, requires 3D printing to fabricate. Autodesk cloud-based Fusion 364 software was also integral to the shoe's concept development and refinement. Here's another example in the real world, a bridge construction happening right now in Amsterdam. Dutch design and tech R&D studio MX 3D won a commission to 3D print a bridge central Amsterdam. Based on Joyce Lamon's innovative 3D printing system for metal suspended in the air using 6-axis robotic arms, material will be a steel composite developed at the University of Delft. Given material and the freedom of the robotic arm, the system is well suited for large-scale infrastructure type of projects. Team with Autodesk for generative design technology to minimize material use but also create an aesthetically stunning bridge. Autodesk is also contributing expertise on the robotic printing system, tackling the challenge of 3D printing in open space without the controls and consistency of a normal print bed. Bridge expected to be complete in late 2017. The finished bridge will be around 20 feet long, support normal Amsterdam foot traffic, and feature a beautiful, intricate design and that looks far more handcrafted than the detailing of most bridges now in Amsterdam. Because 3D printing allows for a granular control of details that industrial manufacturing can never deliver before. Designs can be much more ornate and almost bespoken in appearance. One more, not a customer per se, more of an Autodesk collaboration with the Bandito brothers, a group of stuntmen and a filmmaker based in Los Angeles, and a research project which is called the Hack Rod. This project represents the final connection on design, make, use, wear, where sensor data plugs into and informs design. The team built a prototype car chassis. They rigged it with hundreds of sensors before driving it around the Mojave desert, bringing in volume data about the forces the chassis was subject to that could normally only be collected by a well-funded professional racing team. The plan has been to take all the data from the automotive nervous system and plug it into Autodesk Dreamcatcher, a generative design software system that takes input of design objectives, including types of materials, functional requirements and goals, methods of manufacturing, performance criteria, and even cost limits. And it spit out numerous design alternatives to satisfy all those requirements at the same time. Intended to maximize driving performance and efficiency, it could never have been designed by humans. The Hack Rod's team wants to ride the same wave. Every time the vehicle's rubber hits the road, it brings in more information through all those sensors. Literally billions of data points in just hours of driving, and all of that is then plugged into Dreamcatcher. Every session means the car theoretically gets better and better, smarter and smarter. Autodesk, as a company, has not only seen such transformation before in our 30 years more history, but help our customers navigate them and exploit the opportunities created by them. The first was the era of documentation. We all know that. In the early days of CAD, Autodesk was the disruptor. When we went from pencil and paper and moved 2D drawings to the computer. The drawing was accurate and precise via geometry, diagrams, and text, but it was still just a drawing. Decisions about the design still have to be made through intuition and judgment and experience and the intelligence of a design was still contained in a physical drawing. And so the industry moved on to the next disruptive technology, 3D modeling. We all know in ACE industry is the BIM. This was the era of optimization, from 2D CAD to 3D digital models, from merely documenting design to simulating and analyzing how a design will work in reality, enabling us to improve the performance of our designs before we build them. These 3D behaviorally predictive models provided us with more profound insight, more accuracy, predictability, and precision. This information led to a greater understanding of how things go together, but that's not enough. And now we are entering, and also we have a chance to lead a new era, the era of connection. We're going beyond simply optimizing a design. We have to optimize how a product is built and the physical digital systems that interconnect with them, where the digital and the physical are deeply integrated. The lines are blurring. Advanced forms of manufacturing will become the norm. And literally billions of dollars will be saved through the convergence of the design, make, and use phases, and the leap forward in efficiency and productivity afforded by new technology and the data it provides. And while how things are designed and made will be changing, so too will the way we work fundamentally shift. Anyone, anywhere, on any device will be able to contribute to a project in real time. Barriers to productivity will disappear. Since our founding over 30 years ago, Autodesk has always helped its customers navigate these profound areas of technology disruption and opportunity. And we continue to do so with a portfolio of products unparalleled in the design world. And certainly, we'll provide you with these tools in new ways that will enable you, no matter your industry, to work in precisely the manner that best suits your needs and provides you with the opportunity to flourish in this new era of connections. Autodesk 2017 solution launched today will help you stay at the forefront of design in your industry. Hope you all will have a splendid and fruitful day with us today. Thank you very much.